Alright, in this video I'm going to look at Euler circuits. We'll be using the Euler circuit for the Chinese postman problem, and it's a little bit more complicated than the problem, but to get started with that you need to understand what an Euler circuit is. First of all, in order to find an Euler circuit in a graph, you have to have a graph where every vertex is of even degree. Remember what degree is. Degree is the number of edges entering a vertex. So A is degree 2, B is degree 1, 2, 3, 4. C is degree 1, 2, 3, 4. D is degree 1, 2. And E is degree 1, 2, 3, 4. All right, so those degree values, 2, 4, 4, 4, 2, 4, those are all even numbers, which means that my graph has an Euler circuit. If those are not all even numbers, the graph does not have an Euler circuit. You'd have to do something like what we would call Eulerizing the graph in order to make that happen. In other words, if I started out with this picture where C and E are both degree 3, what I would do is I would simply add another edge between those, making both of those vertices degree 4, right? And that's called Eulerizing the graph. Now, with an Euler circuit, we're going to start and end at the same vertex. In the Chinese postman problem, we're going to be starting and ending at home. Let's call our home base vertex A. And with the Euler circuit, you have to make your way around this network, and you have to cross every edge exactly one time. So if you're the postman and you have to deliver mail to all of these different streets between the intersections, the streets represented by the edges, the intersections represented by the vertices, you have to cross every street one time. And let me just show you how you might do that. Right? So if I were to go this way first, cross that one, deliver my mail, go down here, deliver my mail there, go from this intersection to this intersection, deliver my mail, go back up along this street to B, back down this street to C, across from C over to E, then back from E to C, we deliver the mail, and then we go back to our starting spot. All right, so if I follow that again, this is 1, 2, 3, 4, 5, 6, 7, and 8. Right? That would be the route that I took. I traveled those streets and came back home. Right? That's an Euler circuit. Euler circuit. Now, for the graphs that we are going to be using in this class, it'll be pretty easy for you to find the Euler circuits using a trial and error method. There are some algorithms that we could use to help you find Euler circuits, but I'm not going to get into those in this course. All right, so that's an Euler circuit, and remember, in order for an Euler circuit to exist, the vertices must all have even degree. And an Euler circuit, you start and end at the same spot, and you cross every edge. Remember, Euler starts with E, and edge starts with E